Now for part D, this is the hardest one on this page, and I have to warn you, and this is kind of true for a lot of these, there's actually more than one way to do most of the problems on this page, and that's kind of typical of exponents in general. So you often don't know like the one right way to do it. It's just that you have to follow those 5 rules on the first page of notes, the page 66. You have to just keep following those rules and following them and keep trying stuff and trying stuff until you find the right answer. So it's not like there's one right way to do part D. So I'm just going to show you one of the ways, and you can take it for what it's worth. So, and again, I'm not claiming this is the best way. I just think this is probably the simplest for students to get their heads around. So the first thing I want to notice is that I want to simplify what's inside that parentheses a bit. So let me type it up. All right. Now you can notice, I mean, 2 over 3, that's done. That's not going to simplify, right? But you have something else going on in here. You have the b's. So you have b to the -4, take away 2. And you have c to the +4, take away -9, or -5, excuse me. Oh, if I could type the number 5. All right. And then again, it's all raised to the -3 power. I haven't dealt with that part yet. Okay. So this is equal to 2/3, fine, b to the -6, c to the 9, because 4 minus a -5 like that is really 4 plus 5, and 4 plus 5 makes 9. And this is again still all to the -3rd power, no troubles. Okay, so this is equal to 2c to the 9 over 3b to the 6, all to the -3rd. Now, again, I have really not dealt with the whole -3 thing. All I've done to this point, this is deal with the inside the parentheses, which is actually quite a bit like the last problem. You got this 2 over 3 business, and then the c's ended up being 4 minus a minus, which became plus, so it stayed on top. And then the b's became -6 right here, and that's negative power, so that went to the bottom. Okay? So I simplified what was going on in there. Now at this point we have a choice. You can try to distribute your negative power, right? Which is probably what most students would think of doing, which is fine. So you say, okay, it's 2 to the -3, and then c to the 9 to the -3, and then 3 to the -3, and then b to the 6, to the -3. You're distributing, right? You're sending that -3 power to everything that's in there. Okay, well, fine. So what is that going to make? It's going to make it, and I'll deal with this in a second. So 2 to the -3, I know. It's still negative, I'll deal with that. But I wanted to kind of simplify this. This was -27. You multiply those powers. 3 to the -3, b to the -18. Everything with a negative power has to move. So what was in the numerator becomes the denominator and vice versa. So it's going to become 3 to the 3, b to the 18, 2 to the 3, c to the 27. When you move them, they don't have their negative powers anymore. Now, this is all done except for you're not supposed to leave 3 to the 3rd and stuff. You're supposed to be able to find those numbers. So that's 27, b to the 18, 8, c to the 27. Yes, I know there were other ways to do that if you liked, but I just want to show one way. Otherwise, everybody will get all confused about, I literally can think of 4 different ways off the top of my head to do this problem. So I just kind of kept going. I tried to simplify inside. I got rid of my negative exponents inside. And then I distributed, but that gave me nothing but negative exponents. So then I flipped everything around and simplified again. You just keep going, going, going until you're all simplified. No parentheses, no negative powers, none of it, right? Just whole numbers and positive numbers, except maybe if there was a negative in front, that would be fine. All right, we're done with that page. Let's go to an exponential function. Very important. So an exponential function is a function. Remember those we learned about in chapter 1. They mean every input goes to only one output, passes the vertical line test, all that good stuff. So it's in a function whose equation can be put into this form. F of x equals a times b to the x. A cannot be 0. B must be greater than 0. This will only be for positive numbers for b. And b cannot be 1 because 1 to the any power is still 1. So that won't work. Okay, so this is a really big deal. I can't stress this enough. So remember the first 3 chapters, we did y equals mx plus b. And then we said, oh, but that's f of x equals mx plus b. F of x equals mx plus b all the time. That's because those 3 chapters are dealing with lines, straight, diagonal, vertical, horizontal lines. Mx plus b is the equation of a line. Well, y equals mx plus b. We are not doing those anymore, not in this chapter. In this chapter, we're doing exponentials, which their basic form is a times b to the x, right? So the b is called the base, very important. And a is the coefficient, if you will. All right, so I have a function here, f of x equals 3 times 4 to the x. You are to find the following. F of 2. So what you're going to do is you're going to put 2 into that. So you're going to say, okay, that's 3 times 4 to the 2. Now, order of operations. Let's remind ourselves. Order of operations is PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, then multiplication and division. They're the same. You just work them left to right. And then addition, subtraction. Okay, so here I'm going to have to do this exponent first before you multiply. That's the biggest mistake students make, because they go, oh, I know 3 times 4. 3 times 4 is 12. Yeah, I know that too, but that's not what you should be doing. The exponent trumps that. So you've got to do the exponent part. So it's 3 times 16. That's what you need to do, which, by the way, is 48. Okay, and if you think about, if you did the multiplying first, you'd get 12 to the 2, right? And 12 to the 2 is 144, which is totally wrong. Okay, so you have to do exponents before you do multiply. Let me just write it down. Please excuse my dear Aunt Sally. Right, that's the order they go in. Hold on, let me make this. There we go. That is the order of operations. So you have to deal with exponents before you can deal with addition or multiplication. Okay. So then what about number 2, or letter B, sorry. So letter B, we're going to do the same thing, but it's going to be negative, right? So it said 3 parentheses 4 to the negative 2, which is, careful, who goes to the denominator? You see that negative power, something's going to the denominator. And it's only the 4, because the 3 is outside of that parentheses. So you do 3 on the numerator, and then 4 to the 2 in that denominator, which is 3 over 16. Like that. Don't just write 3 over 16. Write how to get it. That's the most important part for your notes. All right, C and D are really, I think, a little bit confusing. And the author throws them in there, so I want to make sure you guys know how to do it. And it's really a little tricky. So this is 3 times 4 to the a plus 3. A plus 3. Now, this is where it gets dicey, because you're thinking, okay, I'm done. A plus 3. And I would love to say that you are, but you're not. You've got to remind yourself about something. Remember the property that said, and I got to close this, hold on. Way back at the beginning, right here. Do you see that? Let me bring it down. Let me remind you guys of all this. So when you have 2 powers added like that, right? Normally we don't go this direction, but let me just do a little reminder. That. So if you look at what I have, 4 to the a plus 3, see that? 4 is my b, a is my p, 3 is my q. See it? So what I can do is I can go backwards, right? And use that property and go the other direction, a direction I'm not actually usually used to going. So let me put it right. Hold on one second. There we go. Oh, I hate that feature of the new Windows. They keep trying to make it like Macs, and I hate it. I don't like it on Macs either when it's resizing my windows all the time on me. Okay, so 3 times, now here's where it's going to get interesting. It's 4 to the A times 4 to the 3. Now, see, could you go backwards with this? Right? 4 to the A times 4 to the 3 makes 4 to the A plus 3, right? You're used to going that direction. You're used to looking at, here, you're used to looking at 4 to the A times 4 to the 3 and saying to yourself, oh, okay, that's 4 to the A plus 3. Just add the powers, right? You're used to going from this step to here. But I'm not doing that. I need you to go the other way. So you're going to break it. So in other words, you're starting at the right-hand side of that rule and going back to the left-hand side, which is strange, right? You can do it because equations, because it's an equal sign, means you can go either direction. You can go from left to right or right to left. But in this case, we want to go from the right to the left. Okay, so wait a second. 3 times 4 to the A times 4 to the third, but 4 to the third is 64. And 3 times 64 is 192. Right? And again, you don't have to do parentheses, but it's kind of neater if you do. You could also do the dot thing, but that gets a little confusing because it looks like a decimal point. That's one of the many reasons that they don't like the dots. Mathematicians don't like the dots for multiplication because it gets a little messy. So there you go. So there's your f of a plus 3. Like that. I know it's confusing. Write it down. That's how you have to work that. You have to be able to go the other direction with this rule. This rule right here. All right. Do you want to take a guess what D is? D is another one like this. So let me put in a reminder. Here, it's not the same reminder, so let me get you to see it. So I want f of a 3a, right? Okay, so I want 3 times 4 to the 3a. Okay, well that's not the same as the other one. The other one had adding up there. See that? At a plus 3. Now I've got timesing. So let me go back to the front page, and it was right here. Look at number 5. You got timesing on that one. So you're going to go backwards on that particular thing. If I could find the page. There we go. I pasted it back in. So this is going to mean equal to 3 still times 4 to the 3 to the a. I'm breaking up. I'm going backwards. I had 3 times a, so I put the 3 inside where that p is, and I leave the a outside where that q is, and b is 4 for me. But this is equal to 3 times 64, because 4 to the third is 64, to the a. Now I know those are confusing, so just write them down and pay real close attention so you can do those on your homework. You're basically just using those rules and going backwards. Now the last bit of here on this page is to compare e of x, which is 2 to the x, which is exponential, and L of x, which is 2x, which is linear, right? This is mx plus b, it's just that b is 0. So I've labeled them. The exponential one is this red one, this maroon one right here. And you can see that the exponential is a curve. It does not have the same steepness throughout. It starts out really shallow and gets steeper and steeper and steeper as the graph goes on, which means it's also growing very fast, much faster than the linear graph. And it never crosses the x-axis. It just kind of skims along it down here at the -4. It's getting so small you can barely tell the difference, but it's not going to actually touch the x-axis. The linear one has a straight, steady slope, always the same throughout. It crosses the x-axis, and it does not grow nearly as fast as an exponential function, which of course is very important to which kind of models we would use for each of these. Exponential ones get used in biology and finance a lot.